device that is constantly creating billions of electronical impulses every second, and we never even stop to think about it. Computers are one of the most complex creations we've ever been able to create, a device that has every piece of information that we could ever want. But if we look at it on the molecular level, how it works doesn't have to seem so hard to understand. The big star in these processes are called transistors. These small conductors are bridges that allow electricity to travel from one place to another in a fraction of a millisecond. And they're not only used in large-scale computers. So much of what we see in everyday life is made up of transistors. Lights, TVs, cell phones. Your average iPhone has billions of transistors in it, so wouldn't it be interesting to see how it works? I am currently studying computer science and have spent more than half my life around computers, so this topic endlessly fascinates me. There are three main points regarding transistors that I want to cover: what they are made of, the flow of electrons in copper, and what the three leads in a transistor do. Visualizing these concepts can be pretty difficult, so allow me to give you an easier to understand picture created by a professional artist. Transistors are small pieces of silicon and copper that act as bridges for currents to travel over. Here's a more realistic, but significantly more boring picture of a transistor. Transistors fit into a bigger system known as a NAND gate. A NAND gate is essentially a system that waits for a signal to act on its duty. For example, Maxim Integrated's Dictionary for Analog Devices tells us that it's much like a security system. The security system would be set up to send a signal to a NAND gate when a window is open, thus setting off an alarm. However, NAND gates are complicated and too much info for right now, so let's just focus on transistors. Copper wire is one of the primary materials used in transistors because it is a semiconducting material, whereas rubber here is not able to conduct these electrons. Now that we know what they're made of, let's look at how they actually operate. What would happen if we were to introduce an insulator to this copper piece? The flow of electrons would stop right in the middle because it is being insulated by the insulator. However, if we were to introduce a semiconductor, it would be able to insulate and conduct. Now that we have the semiconductor, we introduce a current to the semiconductor, and the electron flow goes through the copper wire. This is equivalent to any electrical source as long as it's electricity. As I said before, understanding something like a semiconductor isn't as hard as you'd think. So now that we know how a current affects an insulator, let's look at how it affects a transistor. Essentially, what we're trying to do is to get a flow of electricity from one side to the other. The three leads are basically lead 1, the insulator, and then lead 3. And our objective is to get a flow of electrons from lead 1 to lead 3. The flow of electricity in a transistor is exactly what we just looked at, only in a different formation. For example, let's put an LED colored light on this transistor. Once the current is provided to the insulator, the flow of electrons is moved to the right side and the light turns on. Once it's removed, the light turns on. Very rarely do we stop to consider what is really going on in something as common as a phone or a television. But once we break it down to a basic level, it really isn't so complicated. Hopefully now, when you see these things, you might stop and think about the billions of processes going on inside. Thank you.